Good day everyone, my name is Archie D. Cordero, a 3AB Psychology A student. So we are now done with the chapter 3 of the psychological assessment that refresh us from the statistics. Now, on this chapter, we discuss the overview of the elements of good test. In order to understand the next and following topics, I will now first introduce to you the fundamental assumptions that will be expounded by the following reporters later on. Now, I present to you the 7 assumptions in psychological testing and assessment. First, we have the assumption that psychological traits and states exist. The assumption number 2, which is psychological traits and states can be quantified and measured. Assumption number 3, test-related behavior predicts non-test-related behavior. Assumption number 4, test and other measurement techniques have strengths and weaknesses. Assumption number 5, the various sources of error are part of the assessment process. Assumption number 6, testing and assessment can be conducted in a fair and unbiased manner. And lastly, testing and assessment benefits society. First, we have the assumption that psychological traits and states exist. In order for the psychological test and assessment to be measured, we must first remember that traits and states are what we specifically purport to measure. So let us first discuss what is trait. Trait is any distinguishable, relatively enduring way in which one individual varies from another as Guilford 1959 had defined. As you can see, I have put emphasis on the words relatively enduring. What does that mean? It means that trait does not always show itself in our behavior 100%. Most of the time, it is dependent on the situation. For example, we can say that a person is kind. Although we know this, it is also a fact that it is not always shown in every of their actions. Or we may become less agreeable as we grew older. Just like a person, trait 2 is dynamic. States, although similar to traits that it distinguishes a person from one another, is relatively less enduring. This is really important in diagnosis. To give you an example, anxious, fearful, and unstable are adjectives that can be under the states. However, unlike the trait that is relatively enduring and lasts longer during a person's lifetime, states do not. Are there individuals that do not believe about the existence of psychological traits and states? Well, although there are few individuals who does, and for them, they believe that for something to be accepted as existing, there should be an observable and tangible material to prove it. As you can imagine, individuals that do not believe about the existence of the traits and states demands for their physical representations or parts of the brain that they occupy. However, we must remember that psychological traits and states are all constructs. An informed scientific concept developed or constructed to explain or describe behavior, which can be inferred using overt behaviors. In determining a trait, the context to which the behavior occurred is also important. For example, if you saw someone praying and kneeling inside the church, one can infer that the person is religious. However, when you say the action being done is in front of the mass of strangers at the center of the road, one can say that the person is insane and or paranoid. So we have there the assumption number 2, which is the psychological traits and states can be quantified and measured. Now that we have proven the existence of psychological traits and states in the form of constructs, these specific traits and states should be defined to be clearly measured. Remember that the test developed should measure what it purports to measure in accordance with the definition that the test developer had used. Meaning, if you are to measure intelligence through the use of testing and assessment, questions should be highly relevant to this area and should reflect on the definition of intelligence that the developer presented. Next, weighing factors in a test is dependent on what value the society attached to the behavior or by the test developer. It always comes with the necessity of the test to the society. Using the former example, if the society deemed that the more street-smart an individual is, the smarter he is, or if the test developer had concluded that knowledge regarding crystal structure is what intelligent individual possesses, test items in these areas may be included as long as it is justified and backed with evidences. Now, how will be the scoring done? The attribution of score to the test is also dependent on the society and on what the test developer deemed to hold more relevance. If they both believe that being street smart should score higher for a person to be called intelligent, then the person who developed the test or the test developer will put more weight on the area of street smart in terms of scoring and put lesser emphasis on score of score in crystal structure despite them both being acknowledged as necessary for them to label a person as intelligent. Since we have already put weight on the scoring and the traits that is measured had been clearly defined, it now can be measured. It is mostly done using the test score that represents the strength of the targeted ability of trait, which is often based on the cumulative score or the running sum of the proportion of times specific scores occur compared to the total number of individual score occurrences in a set of data. Now we move on to the assumption number 3, which is test-related behavior predicts non-test related behavior. Patterns are true or false in personality tests such as MMPI-2 or Minnesota Multiphasic Personality Inventory number 2 are used in decision making regarding mental disorder. MMPI-2 is designed to measure characteristic patterns of traits that people exhibit across various situations. The result of the test actually shows the deviance of a person in different situations, be it low or high from normal, that may be a symptom of a specific mental disorder. Also, some of the question and tests will predict the future behavior of the test user. For example, the MBTI or the Myers-Briggs type in the type indicator is a personality test. However, it can also predict their behavior inside the company or if the person can work within a group. So that's it for the example. Now we move on for the assumption 4. Tests and other measurement techniques have strengths and weaknesses. Right now and maybe on the coming years, the development of a perfect test might not come. Of course, yes. However, as of now, every test has their own weaknesses and strengths, and it is under the test user's discretion on how they will utilize it. Test users know and understand the test they would use, its purpose, its process of administration, to whom should it be administered, and more importantly, how they will interpret the results. Of course, as they know well about the test they are using, they also understand that each has their own limitation that they can compensate using other sources of data if it is lacking. Assumption number 5, various sources of error are part of the assessment process. Of course, as there are limitations, strengths, and weaknesses on the test develops, there should be also error. However, we must remember that these errors are not the mistakes or miscalculations done, but something that went beyond what is expected. Error, by definition, used in testing and assessment, refers to the long-standing assumption that factors other than what a test attempts to measure will affect the test taker's performance, and this is called error variance. There are potential sources of error variance. First, the assessee. If the test taker has a flu, cold, fever, or anything that will affect their performance, that will be a factor. Second is the assessor. Depending on how they will administer the test, the environment, instructions, and of course, the target which the test will be administered. And lastly, the measuring instruments. The question here is, are the measuring instruments appropriate to measure what the test user is measuring? If not, then there is an error of variance. Number 6, or the assumption number 6, testing and assessment can be conducted in a fair and unbiased manner. Just like any tools created by humanity, testing can be misused depending on the test user. They can use this test to justify their actions, although it is very unethical and or manipulate someone knowing that they are susceptible to it. However, it can also be used properly by following standards and ethical protocols. And the last assumption is that testing and assessment benefits society. Tests and assessments were really crucial in the development of the humanity and will always be. Imagine a world with no tests. Well, for students having to take midterms as semestral examinations, it would be a world of bliss. However, if we don't have these tests and assessments, the world itself could fall to ruin. Imagine giving a position to someone incapable. Imagine letting a student graduate without learning anything. Or imagine you are inside the plane and the pilot do not even know the basics of flying a plane. The world will turn upside down as we can just put anyone in positions without testing and assessing their ability to that specific chair. So I guess I have finished my reporting regarding the 7 assumptions on psychological testing and assessment. The next reporter will continue the topic for this chapter. And yes, again, I am Archie Cordero from 3AB Psychology A, and thank you for listening.
Del Monte, a third-year AB psychology student from the University of Southern Mindanao, Cabacan campus. And now that we're through with the 7 assumptions about psychological testing and assessment, let us now proceed on the criteria of a good test, where it also covers reliability and validity, which also the topic outline of this report. So before I proceed to the main topic, I will first give a brief description about the word test. So I know for sure that all of us do know what a test is. We experienced it already, especially as students. So, a test is a way of discovering, by questions or practical activities, what someone knows or what someone or something can do or is like. And now, the question is, what is a good test? In here, I have 3 criteria of a good test. So, the first one is clear instructions for administration, scoring, and interpretation. So, according to Roberts and Davis in the year 2015, a big error that can occur with administration of psychological tests is not giving the instructions to the test subjects verbatim. So it is really important that the test manual should contain full instructions from the test administration itself up to the scoring interpretation. So second, a test offered economy in the time and money it took to administer, score, and interpret it. And lastly, a good test would seem to be one that measures what it purports to measure. So aside from the 3 mentioned, there are also technical criteria that assessment professionals use to evaluate the quality of tests and other measurement procedures, and that is reliability and validity. First one is reliability. A good test should be highly reliable. The keyword here is consistency. This means that the test should give similar results even though different testers administrate it. Different people's scores and different forms of the test are given, and the same person takes that test at 2 or more different times. If not, the method of measurement may be unreliable. Reliability is usually checked by comparing different sets of scores. In actual practice, psychological tests are never perfectly reliable. One reason is that changes do occur in individuals over time. For example, a person who scores low in her group at an initial testing may develop new skills that rise her to a higher position in the group at the same time of the second testing. Now that we realize the importance of a reliable measure, we will discuss why reliability is important in exam planning and selection. Imagine, for example, that you are to take a test of cognitive ability and score highly. Feeling proud of yourself, you decided to take the test again to prove to your boss that you are a genius. However, your score the second time places you below the average cognitive ability. Confused by the difference in the score, you take the test a third time, scoring even lower on the third try. What is going on? Could it be that you are getting dumber as the minute pass? More than likely, the test is not a reliable measure of your cognitive abilities. If such a test were used to select applicants, it would be no better than if you had selected the applicants by drawing their names from a hat. The higher the reliability of a selection test, the better. Reliability should be 0.70 or higher. If a selection test is not reliable, then it is a useless tool for selecting individuals. We want to be reasonably certain that the measuring tool or test that we are using is consistent. That is, we want to know that it yields the same numerical measurement every time it measures the same thing under the same conditions. Psychological tests, like other tests and instruments, are reliable to varying degrees. For example, if a person wants to measure their height using a tape measure during the course of a day, then they should expect to see a similar reading. If it is not, then it would be of little use because it is not considered reliable. Now that we're through discussing what reliability is, let us now proceed to the methods of determining reliability. And the first one is the test-retest reliability. First one is the test-retest reliability. So the test-retest reliability is probably the most common method of assessing reliability. Assessing test-retest requires using the measure on a group of people at one time, using it again on the same group of people at a later time, and then looking at test-retest correlation between the two sets of scores. The key here is that while there is no ideal time period between testing, the time should be long enough to reduce carryover effects, but short enough so that the attribute of interest has not changed. For example, suppose researchers give a test to 20 individuals and then give the same type of test 1 month later to the same 20 individuals. The two scores are then correlated. The smaller the difference between the two sets of results, the higher the test-retest reliability. Again, high test-retest correlations make sense when the construct being measured is assumed to be consistent over time, which is the case for intelligence, self-esteem, and the big five personality dimensions. But other constructs are not assumed to be stable over time, just like the very nature of mood, for example. That there are also potential biases in test-retest reliability. Test-retest is a useful metric to calculate, but be aware of the following potential biases that could affect this metric. The first one is practice effect. A practice effect occurs when participants simply gets better at some tests due to practice. This means they are likely to show better results during later tests because they've had time to practice and improve. The second is the fatigue effect. A fatigue effect occurs when participants get worse at some tests because they get mentally drained or fatigued from taking previous tests. The third one is differences in conditions. When participants take the two tests under different conditions like different lighting, different time of the day, different time allowed to complete the test, it is possible that they score differently on the test simply due to differences in the testing environment. Alternate forms reliability, or the consistency of test results between two different but equivalent forms of a test. Alternate forms reliability is used when it is necessary to have two forms of the same test. A test would be deemed reliable if differences in one test observed scores correlate with differences in an equivalent test scores. Alternate form occurs when an individual is given one form of the test and after a period of time, usually a week or so, the person is given a different version of the same test. If the scores differ dramatically, then something is wrong with the test and it is not measuring what it is supposed to. If this is the case, the test needs to be analyzed more to determine what is wrong with the different forms. In alternate forms reliability, unlike the first one, here it is ideal that the administration of the two forms should be done in a short time span. And just like the test-retest, it also has these advantages. First, you have to create a large number of questions that measure the same construct. Proving that the two test versions are equivalent can also be a challenge. Let's proceed to the last method, which is internal reliability. Internal reliability deals with the test items. This is different from test-retest and alternate forms reliability, which deals with the way test takers perform. Internal consistency represents the degree to which items in a test are functioning in a similar way. An internal consistency estimate of reliability is computed using only a single administration of the test. And that is one of the reasons internal consistency is used more often. Now, in determining internal reliability, we have here the split half method. So, the split half method assesses the internal consistency of a test, such as psychometric tests and questionnaires. There, it measures the extent to which all parts of the test contribute equally to what is being measured. This is done by comparing the results of one half of a test with the results from the other half. A test can be split in half in several ways. Example, first half and second half are by odd and even numbers. If the two halves of the test provide similar results, this would suggest that the test has internal reliability. The split half method is a quick and easy way to establish reliability. However, it can only be effective with large questionnaires in which all questions measure the same construct. This means it would not be appropriate for tests which measure different constructs. For example, the Minnesota Multiphasic Personality Inventory has subscales measuring different behaviors such as depression, schizophrenia, and social introversion. Therefore, the split half method was not be an appropriate method to assess reliability for this personality test. So under the split half method is this what we call Spearman-Brown proficiency formula, wherein the formula is 2 times split half correlation over 1 plus split half correlation. So if we have a split half correlation of 0.70, then the corrected reliability would be 2 times 0.70 over 1 plus 0.70 equals 1.4 divided by 1.1 equals 0.82. We also have here the Cronbach's coefficient alpha. So Cronbach's alpha or coefficient alpha is developed by Lee Cronbach in 1951 to measure reliability or internal consistency. So it is used for items in which students are given points such as essay questions or the dichotomous formula that is used for right or wrong answers. So Cronbach's alpha is a way of assessing reliability by comparing the amount of shared variance or covariance among the items, making up an instrument to the amount of overall variance. The idea is that if the instrument is reliable, there should be a great deal of covariance among the items relative to the variance. Cronbach's alpha is equivalent to taking the average of all possible split half reliabilities. Most computer packages for statistics in wide use today can compute Cronbach's alpha. So often it is helpful to examine what the Cronbach's alpha becomes after a particular item is deleted. If Cronbach's alpha goes up considerably upon deletion of an item, the item may not belong in the measure. Cronbach's coefficient alpha is used primarily as a means of describing the reliability of multi-item scales. Alpha can also be applied to raters in a manner analogous to its use with items. So using the alpha in this way allows us to determine inter-rater agreement when the ratings entail non-categorical data, for example, the degree of emotionality on a scale of 1 to 10, and various units of text. So scale items and raters both are in essence indicators of information about a phenomenon of interest. There are a number of different formulae used to compute a test internal consistency, and another one is the Kuder-Richardson or KR formula used for right or wrong answers such as multiple choice test items. So the Kuder-Richardson formula 20 or KR20 is a measure reliability for a test with binary variables, example answers that are right or wrong, just like what I've said. So the KR20 is used for items that have varying difficulty. For example, some items might be very easy, others more challenging. It should only be used if there is a correct answer for each question. It shouldn't be used for questions with partial credit is possible or for scales like the Likert scale. So the scores for KR20 range from 0 to 1, where 0 is no reliability and 1 is perfect reliability. So the closer the score is to 1, the more reliable the test. So as you might expect, however, reliability is necessary, but reliability alone is not a sufficient element of a good test. In addition to being reliable, tests must be reasonably accurate, or in the language of psychometrics, tests must be valid. So in here we have the validity. And according to Hatch and Faraday in the year 1982, validity refers to the extent to which an instrument really measures the objective to be measured and suitable with the criteria. Or in other words, a test can be said to be valid to the extent that it measures what it is supposed to measure. If the test is not valid for the purpose for which it's designed, the scores do not mean what they are supposed to mean. And there are also three common ways to measure validity. The first one is the content validity, or the extent to which a test measures a representative sample of the subject matter or behavior under investigation. So, for example, if a test is designed to survey arithmetic skills at the third grade level, content validity indicates how well it represents the range of arithmetic operations possible at that level. So the second one is the criterion validity, or the extent to which people's scores on a measure are correlated with other variables known as criteria that one would expect them to be correlated with. For example, people's scores on a new measure of test anxiety should be negatively correlated with their performance on an important school exam. If it were found that people's scores were in fact negatively correlated with their exam performance, then this would be a piece of evidence that these scores really represent people's test anxiety. But if it were found that people scored equally well on the exam regardless of their test anxiety scores, then this would cast doubt on the validity of the measure. So, under the criterion validity, we also need to familiarize these three terms. First is the concurrent validity, where it measures how well a new test compares to a well-established test. It can also refer to the practice of concurrently testing two groups at the same time, or asking two different groups of people to take the same test. For example, if you create a new test for depression levels, you can compare its performance to previous depression tests like a 42-item depression level survey that have high validity. Concurrent means at the same time, so you would perform both tests at about the same interval. You could test depression level on one day with your test and on the next day with the established test. A statistically significant result would mean that you have achieved concurrent validity. If the tests are further apart, for example, they aren't administered concurrently, then they would fall into the category of predictive validity. So, predictive validity, on the other hand, if the test accurately predicts what it is supposed to predict. So, for example, the SAT exhibits predictive validity for performance in college. It can also refer to when scores from the predictor measure are taken first and then the criterion data is collected later. So, lastly is the validity generalization, refers to the demonstration that the validities of various selection devices generalize across different settings, or whether validity coefficients obtained in prior studies in organizational environments may be used to forecast the value of a validity coefficient in a new but similar organizational environment. So the last one is the construct validity, or where it is used to ensure that it actually measures what it is intended to measure, example the construct, and not other variables. So using a panel of experts familiar with the construct is a way in which this type of validity can be assessed. The experts can examine the items and decide what that specific item is intended to measure. For example, if a researcher develops a new questionnaire to evaluate respondents' level of aggression, the construct validity of the instrument would be the extent to which it actually assesses aggression, as opposed to assertiveness, social dominance, and so forth. So, a variety of factors can threaten the basic construct validity of an experiment, including first, the mismatch between the construct and its operational definition, various forms of bias, and lastly, various experimenter effects and other participant reactions to aspects of the experimental situation. But just because a test is reliable does not mean it is valid. I'm sure you've heard this phrase before. So, one example for this is you are looking for a typist and you want to use height as a requirement. So, to measure the height, you use a tape measure, so it would certainly be reliable since most adults will get no taller at the same time, and two people measuring an applicant's height will probably get very similar measurements. It is doubtful, however, that height is related to typing performance. Thus, a tape measure would be a reliable measure of height, but height would not be a valid measure of typing performance. And even though reliability and validity are not the same, they are still related. The potential validity of a test is limited by its reliability. Thus, if a test has poor reliability, it cannot have high validity. But as we saw in the example above, a test reliability does not imply validity. Instead, we think of reliability as having a necessary but not sufficient relationship with validity. So that is the end of my report, and I hope you learned something from this one.